Hello everyone. Today we will discuss one of the mode of operations for block cipher, and what we will discuss is cipher block chaining or CBC. Okay, before we go into details with CBC, we will first discuss what block cipher modes of operations are. So as we already know, in block cipher, the data are processed one block at a time. The length of the block depends on the algorithm to be used. So for TS and also triple DS, the block length is 64 bits, while for AES, the block length is 128 bits. So if the length of the data is more than one block, then we have to break the plain text into several blocks. Each consists of p bit. There are several types of how we connect the blocks, from the first block into the second and so on. And for that purpose, NIST defines 5 modes of operations that can be chosen. Here, the algorithm can be triple dash or AES. Both are considered as secure, but obviously, if you want to be the most secure one, then you need to choose AES as the algorithm for the block cipher. The 5 block cipher modes of operation are categorized into 2. The first one is block modes. The second one is stream modes. For the block modes, we have electronic codebook and cipher block chaining. While for the stream modes, we have cipher feedback, output feedback, and counter. Actually, the difference between block modes and stream modes is that for the stream modes, we can use these block cipher modes of operation to generate a key stream, for stream cipher. So that's the difference. While for the block modes, you have to process the data based on blocks. So we will discuss one of the block modes, which is cipher block chaining or CBC. Okay, so these are the principles of CBC. First, we use same key for each block. So for each block, we always use the same key. The input to the encryption algorithm is the result of the exclusive OR operation between the current plain text block and the preceding ciphertext block. So that's why it is called chaining, because there is a chain between the current block and the previous block. The input to the encryption function here for each plain text block bears no fixed relationship to the plain text block. Because of the chaining, because of the exclusive OR operation between the current plain text block and the preceding ciphertext block, then it is very difficult to find the relationship between the plain text block with the ciphertext block, as the result of the encryption. So the statistical analysis is very hard. Maybe it is invisible. So there is no repeating patterns of bit, bits here. Okay, so we will start with the encryption process. The first block of plain text is applied with exclusive OR operation with IV or initial factor. Here, IV is a data block. The size is the same as the size of the cipher block. So the size is the same as the size of the block. Yeah. IV must be known by both the sender and the receiver, but it must be unpredictable to third party. IV should also be protected against unauthorized changes. So it is a kind of key as well, yeah, but not the key itself. Yeah. So it is a kind of key as well. So the transmission must be secure. The transmission of the IV, yeah, between the sender and the receiver must be done in a secure way. So one of the way to do that is to use electronic codebook (ECP) modes of operation to do the to encrypt, yeah, to encrypt the IV and then send it to the receiver. Yeah, the encryption algorithm here is like this. For the first plain text, then it will be sorted with initial factor. Yeah, be sorted with the initial factor, and then it will be encrypted using the key. Yeah. The result is the ciphertext of the first block. Then for the next blocks, yeah, J from 2 to N, see J here, the Jth ciphertext is obtained from the sort operation between the current plain text block with the previous ciphertext blocks. Yeah? So this one is the ciphertext blocks that is produced from the previous plain text. Yeah? They are sorted and then will be processed, will be encrypted using the key K. So the result will be CJ. Yeah. Okay, so this is the illustration of the encryption algorithm or the encryption process. So P1 here is the first plain text block. It is sorted with initial factor, yeah, and then the result will be encrypted using the key K. The key K, and it produces the first ciphertext block. So this is the first ciphertext block. Now, what about the second block of plain text? It must be sorted first with the previous ciphertext block. Yeah? So, using this mechanism, then the relationship between C and P for each block cannot be obtained, cannot be analyzed, yeah? Because actually the result here doesn't only depend on the plain text, yeah, the ciphertext here doesn't only depend on the plain text in that block, but also depend on the previous ciphertext. Yeah. Okay, so P2 is sorted with C1, and then the result will be encrypted using key K, yeah, to produce the second ciphertext block. Yeah. That always, yeah, that the chaining is applied to the whole plain text, yeah, to all of the blocks of plain text. At the final here, Pn is sorted with Cn minus 1, and then the result will be encrypted using the key K, and we will produce Cn, the end ciphertext. Yeah, okay, so as you can see here, this is the illustration of the chaining. Yeah? There is a chaining between the between a block and the previous block, yeah? Or between a block with the next block. For the decryption here, each cipher block is passed through the decryption algorithm. And the result is then sorted with the preceding ciphertext block to produce the plain text block. So the algorithm here is like this. For P1, then we need to decrypt first, the ciphertext here, the first ciphertext block using the key K. Then it needs to be sorted with initial vector. That's why the sender must also know what the initial vector is. And then for the next blocks, then we need to decrypt the ciphertext of the ciphertext block with the key K, and then it must be sorted with the previous ciphertext, previous ciphertext block here, CJ-1. Yeah, this is the illustration of the decryption. So here for the first ciphertext, first ciphertext block, then we need to decrypt it using the key K. Then the result must be sorted with initial vector to produce the first plain text block. For the next one, then we need to decrypt again the second ciphertext block using the key K, and then it must be sorted with the previous ciphertext block to produce P2. So that process is applied to all of the blocks here, all of the ciphertext block here, and at the end we will get PN, or the end plain text block. Okay. With that chaining, CBC can be used for authentication, because a block of ciphertext here depends on all previous blocks. So if we change just one bit in one block, then it will affect all succeeding blocks. So for example, if we change this here, just one bit of this one, then of course everything will be changed. Everything will be changed here. So that's why it is very good for authentication, to make sure that the data that is sent is not modified during the transmission. CBC also needs initial vector, and it must be known by both the sender and the receiver. It can be a fixed value. It can also be derived from a value that is difficult to be manipulated, and it can be sent using one of the modes of operation, which is electronic code book, before the message is sent. Why ECP is appropriate to be used to send the message? Because it is just one block, so it is very short. So using ECP, it is still secure to send the IV. So we don't need to use other modes of operation, which is more complicated than ECP. Okay, I think that's it for CBC, Cipher Block Chaining. I hope it can be understood, and thank you for watching. We'll meet again with the next topic in cryptography.